Talk, guys.
Thank you. All right, hello everyone. We're going to do a quick presentation, I guess, today on Moloch, which is a new and free way to index your packet capture repository. This is our little logo. We kind of like owls a little bit, so you're probably going to be wondering, as the first question, is there going to be a lot of super awesome owl pictures in the presentation? And there absolutely will be, but actually there aren't any pictures of owls that aren't awesome. And there might be a quiz later at the bar about some random owl facts that we have, and I'll buy you a beer if you can remember it. All right, so first introductions. This is Andy.
Hi, I'm Andy Wick. I'm the developer for Moloch. I am just beginning to learn a lot about the security industry and group, so I'm really just the developer. Owen is the user. He's the consumer of the product that we're working on. Supposedly, I am the chief owl procurement officer. I'm not sure what that means, but that's me. I am not a GUI person, so you'll see in a little bit how wonderful the GUI is, but I think it's still pretty good. My history is I've been at AOL forever. I did AIM backend forever. So if you ever used AIM, you used my stuff.
And this is Andy at work. He's usually laughing at all of us. My name is Owen Miller. I do a lot of IDS signature writing for like emerging threats and stuff like that. I'm very PCAP centric, and I'm the owl wrangler, an anti-malvertising enthusiast, and do a lot of like drive-by exploit kits. And this is usually what I look like at work. All right. So for Moloch, for the overview, like what is it? Well, it's just open source, scalable, IPv4 only at the current time, indexing and database system for PCAP. Provides a, I'm sorry, this is actually yours. All right. It provides a simple web GUI for browsing and searching and exporting the PCAP data, along with web APIs that you can actually access to go ahead and pull back JSON encoded or JSON represented SPI data that we generate, and also the PCAP itself. You can download it from our AOL's GitHub page, and it's basically like AOL search for PCAP repositories. You want to do the next one? Sorry.
So what is Moloch not? So this is important. It is not an IDS. It is not looking at the traffic for signatures and trying to figure out badness going on. It's mainly a forensic tool. So when people ask for features that want to turn it into an IDS, currently we're saying no or maybe at best. It's not an inline device. It's more for getting a mirror or a tap of the traffic. It's not sitting in the middle. It's not expensive because it's open source. The part that is expensive, though, relatively, is you just got to buy the commodity hardware. It's not special hardware, it's just commodity hardware. It's not slow, we don't think, because it's using some pretty cool technology, which we'll go over in a bit. And it loves disk space and memory because it loves to store lots of things.
And like Andy was saying, with it not being an IDS, we like to run it in conjunction with other things on the network simultaneously, like Suricata or Snort, and we rely on that type of stuff for actual deep packet inspection and analysis that would create alerting that would then drive you to the data that will be stored within Moloch. So when we were about to create the project, we're like, well, what's the need that's causing us to go ahead and do this? It's like, well, there's actually kind of a lack of fast and flexible method of capturing and indexing PCAP. A lot of the COTS products that are out there, not going to name any names or whatever, but there's probably some people in here who have purchased them and have seen the the number of zeros on those purchase orders, and it's pretty insane, especially when you're just writing stuff to disk and indexing it. So and there were other open source projects that existed that allowed you to retrieve specific sessions, like if you think of like Squeal, which is pretty awesome. But when you're just like, oh, I have an IDS alert and now I'm just going to run TCP dump with a filter on this one 4 gig PCAP file, that's really not the best way to be able to traverse all of your data. It's a way to get a very specific thing, and we wanted to solve that problem because we wanted to be able to grab just all sorts of stuff whenever we felt like it. So basically, none of the stuff that we found in open source or COTS was really was not cost prohibitive or had the feature set that we really wanted. So Now, of course, if you want to know about why we have an owl logo, it's because owls are silent hunters and go after rats, and we think that's pretty cool because we use Moloch to go after rats at our office, and this would be an excellent visual representation. And his feet are so fluffy, it's adorable. So, as far as uses that you could take Moloch and go ahead and apply it to, your own setups, we primarily use it for real-time capture of network traffic and for forensic and investigative purposes. So if you get some sort of alert that comes in and you're like, okay, well, what were these two IP addresses doing for this time window? It's very easy to ask this system that question and just have it deliver all the PCAP back to you, and also visualize it at the same time. So we really like to use the power of Moloch with the other indicators like intelligence feeds that you get, or if you just like pull down Zeus Tracker or Spy Eye Tracker or whatever else you want, alerting from your IDS and antivirus, and it really helps empower your analysts and your SOC guys to quickly and effectively review actions to determine if it was a valid alert or not and how bad the threat is. Because sometimes you can just watch your data flow back up out to some IP somewhere, and that makes you very sad. So yeah, and also the ability to review past network traffic for post-compromise investigations, provided you can buy enough disk space to keep it around. But you could also use it for a static PCAP repository. The emerging threats guys are setting it up right now, and they're going to take all the PCAP they have from all the malware that they run and go ahead and put it into this so they can actually then start searching it and be able to identify like families of stuff and look at and have like all of the MD5s that would be associated with that, because they tag every single one of the sessions, which Moloch allows you to do on import. And then you can say, okay, well, this action is identified with this family of malware, and then how many MD5s do I have in my setup that do that? And then you can just get that right back to you. It's pretty cool. But you could also use it for collecting PCAP if you're doing like, capture the flag stuff. And then the custom data or custom tagging of data on import, or you could even just put it in front of your sinkhole, your honeypot, or your darknet if you wanted to.
So now we're going to talk a little bit about the developer cool stuff. So Moloch is made up of three basic parts. There's the capture piece, which is what's actually listening for all of the packets. It can be either used to monitor live network interfaces, or you can load in already saved files. The database we're using is Elasticsearch, and I'll go into that a little bit more later. And then there's a viewer process, which is actually providing the GUI and provides all of the JSON APIs. So the capture process. Capture process is a single-threaded C program. It's event-based programming. I've been doing event-based programming forever. It's cool. I like it. Threads are, whatever. You can use it to, the last talk was about it. I was very happy. I was very excited. Like, what's old is new again. You can do manual import of PCAP files, or it can read from the network. It's also what parses the packets and does inspection on various protocols that it understands. We're adding more and more protocols almost daily, and it adds tags, and it does all kinds of cool things. And you'll see in a little bit. And Owen says it's kind of like making owl pellets.
Yeah. It's kind of like it. So the owl ingests everything, and then it basically spits back out what it needs to the database. It's a little disgusting, but it's an owl reference, so it had to go in the presentation.
Database. So we're using Elasticsearch. So if you're familiar with Logstash, Graylog, a number of other products that are using Elasticsearch, Elasticsearch is awesome for searching. Hey, that's what the name is. I first looked at Mongo and some other solutions, but Elasticsearch really impressed me on how well you could do custom searches, and it could store the data in its native JSON format. It's just awesome. If you're not familiar with Elasticsearch, basically you can think of it as a NoSQL database where they changed every single term that you're used to talking about databases with, and use a different term. Someone did put together a nice little cheat sheet that lets you know if you say this in SQL land, it means this in Elasticsearch land. But really, it can do lots of neat things. It does all the sharding for you. You can scale your cluster just by adding new nodes. So if things get too slow or you run out of disk space for your database, you just pop on some new nodes and you're done. Magic elves. Why aren't they magic owls?
I don't know.
Yeah. Oh, there you go. Yes. Okay, the viewer, the GUI part. So when I started this project, part of the reason I wanted to do it is I got to do lots of new things, and I had never done Node.js before. Hey, it's event-based programming. I like event-based programming. People make fun of me for always doing C. Let me do something else. So Node.js it was. It's been a lot of fun. My JavaScript is improving. Let's just put it at that. But I like it. And if you like event-based programming, it's fun. It's what provides the UI. That's really its job. It has very simple authentication. It does digest authentication, and it supports SSL. That's the simple deployment. What I would recommend you do if you're deploying this eventually is you actually stick your favorite web server in front of it and have it do the authentication and just pass a header with the username that logged in. Because digest has a problem with most browsers. You can't log out and blah, blah, blah. So here, probably what you're waiting to see. What does the interface look like? We're going to tease you a little bit. This is what the basic interface looks like. You can see the different functions it has. Here's where you can type in your expression. Here's a timeline of all the data that's collected, and here's all the sessions in that time frame. And then you can, did I click?
Yeah.
You can mouse over and see the countries of source and destination. We'll get to a better demo soon. Okay, so the deployment architecture. There's basically two ways to deploy it. You can do a single box deployment where everything runs on the same machine. We actually have a script that's in the GitHub repository that pretty much does this for you if you answer a bunch of questions and cross your fingers. It usually works. We're improving it. That's the best I can say about it. But eventually it will work right out of the box. And that's what you want to do to just try it out. And that's basically, you'll see it in a little bit. Then what you want to do for a real deployment is actually scale it out. You can have multiple capture processes on either the same or multiple boxes capturing all your data depending on how many taps you have. And then your database you can have on different machines also. Usually you don't want to put your database and the capture processes on the same machine if you're watching gigabit networks because just the right profile of the two different things are so different that you just don't want to have to deal with it. So the way we deploy it, and you'll see it in a little bit, is we have a separate database cluster from the capture processes. One thing I didn't mention before is the capture and viewer processes are always on the same machine. Because basically the capture process writes the data to the disk and the viewer process reads the data to the disk, from the disk. Moloch can use a lot of memory. Elasticsearch can use a lot of memory. The more you throw at both of them, the better. I'm sorry, Moloch can use a lot of disk space. Elasticsearch can use a lot of memory. So the more of each of those that you have, the better it will do, the better it will perform. Really, for Elasticsearch, it all depends on how fast your queries need to be. If it's just one person that is querying it all the time, then it probably doesn't matter how fast it is. But if you have multiple people or you have lots of data, you probably want to throw more boxes at it. But again, they're just commodity boxes.
So this would just be an example of an overall data flow into the system. If a user makes a query into the viewer process, then that would go and query the database cluster to retrieve the SPI data, and then also if the user requested PCAP, it could then retrieve that from the viewer as well and flow it back to them. This is what it would look like with a multi-node setup. For instance, with us, like we have like 9 capture boxes, each with about 40 terabytes worth of storage, and we have about 8 billion sessions indexed at any given time, and we have a 15-node Elasticsearch cluster, and I can query that data set and retrieve back whatever I want in like under 20 to 30 seconds. So it's very, very fast. And then you can go ahead and export the PCAP and save that off if you want. From an input data flow standpoint, this could also, instead of network, it could also just be, like a PCAP file that you have, flows into the capture process, it gets parsed, creates SPI data, that goes to your Elasticsearch database, and then also the packets are then written to disk locally on the capture system. For the output data flow, you have your SPI data that would flow out of your Elasticsearch database through the viewer process back to the user, and also the PCAP files on disk would flow packets back through the viewer and then to the end user. Random bit of owl in the news. This owl was hit at about 60 miles an hour by a Ford Expedition, and it just sat in the radiator grill for the rest of the hour-long ride. And then, like, for the next day as well, until some kid in the parking lot was yelling at this lady, "Hey, there's an owl in your car." And it was totally fine. Didn't even have a broken bone. So, I don't know. I think that's pretty cool. Owls are immortal. So back to SPI data types. So the data that's created by the capture process, we call like session profile information or SPI data. And so these are some of the ones that we actually can create based off of like IP. So just any standard like IP header stuff, source, destination, port, stuff like that. Things off of HTTP, DNS, SSH, SSL, TLS as well. So for instance, if you know of a bad cert that's going around and being used, you can actually look for the serial number of that cert inside of your data set. Also, since we do SSH as well, with we've seen some malware botnets that are tunneling everything, but we always know that the server key is the same every time that's being presented to the client. So we can look for that and be like, oh, that's bad, even though it just looks like an SSH session. And this is definitely not an all-inclusive list. So we can go ahead here and step through how we create session profile information. So this is just a very simple GET request to AOL.com, which is everyone in this room's favorite website and homepage, I know. And just grabbing the fave icon file from it. So here you have just the TCP session transcript. We've left out the file. I'm hoping this isn't too small for people in the back. So that's that. And then up here, this is the SPI information that we create based off of this single session. So basically, the top part here is just we have, based off of the TCP session data, start and end of the session, the data bytes, which is the total number of bytes in the payload of the packet and not the headers. The byte count is the total byte count for the session. So that would include payload and also IP header bytes. The protocol that was used, the IP protocol that was used, port, source, destination. We also do GeoIP lookup to country level. We don't do state or like city or anything like that, because generally we use this more at like an egress point for public internet. So we generally care more about dissecting based upon which specific country things are happening with. And then also the ASN source and destination, which is also very helpful. So then we have our tags inside of our SPI data, and these are custom tags that are applied to this session. So for instance, like HTTP content application octet stream is the file type fingerprint that shows up. And we do like file type fingerprinting actually at like the start of the response of the file that's coming back from the server, and then we index that data. And this would be the MIME type that would be coming from like the file command on the icon file that's being returned back from the server. Also, the get, since it was using the get method, we go ahead and index that. The status code being 200 from the server that's being returned. Node egress is just a grouping that we use. So this sensor is in a group that is monitoring for egress traffic, and then the actual node name. And finally, the session was actually detected as HTTP, so we go ahead and log that as well. And we use this, we do this and it's port agnostic and all that stuff, so it actually detects the protocol itself, whatever port it's running on. Next, in all of these right here, these are just the request headers and response headers. So you can see like the accept header was here and accept language, stuff like that. And every single one of those, whether they exist or don't exist, is something you can query on, which is very helpful. So if you ever see HTTP requests that don't have host headers from a client, sometimes that's interesting. And then finally, the user agent string that's seen, we also grab that, and the host name and the URI. So all of those bits of data are created as SPI data and then stored in the database for indexing and searching. And then you still have the rest of the entire session that's on disk that you can retrieve. And you can find it based upon any one of those things that we've just listed. All right, so I don't know, there's kind of a weird smell up here. I don't know what happened. Did someone have burritos for breakfast? Might have been me, I'm not sure. All right, so you want to go to database next?
So for all the data that we store, we have 3 different methods that it can be indexed. Basically, standard indexing, wildcard, and full text indexing. So examples for standard, such things as port, the protocol type, how many bytes there were, packet counts, et cetera, et cetera. You basically can use equals, greater thans, less thans, whatever you want to query against. We also support wildcard. So for most of the strings and IP addresses, you can use wildcards, so you don't have to know the full thing, and Elasticsearch will automatically find and match based on where you put the asterisk. And you can have the asterisk in the beginning, middle, or end. We also support the CIDR notation for IP addresses. You can also add a port to your IP address thing just for ease of use. And then some of the fields we actually do full text indexing with. And that means that you actually break them up into non-word segments, or you break them up where the non-word pieces are into word segments. And we do that for the ASN, the URI, the user agent, and some of the new email stuff we're doing that too. And that way you can match based on part of the string and not the whole string, and don't have to do the asterisk wildcard searching, which can be inefficient. This is very fast for Elasticsearch to do the full text indexing. So for example, Elasticsearch would break up this URI wherever there's any non-word delimiters, and so you would end up with these tokens, and then you can search for those tokens, and it will find this URI.
So one of the other things that I started noticing with a lot of the full PCAP setups that are out there is you kind of have to search. Like when you want to just search for an IP address, it might be in various locations, and you have to keep writing queries that look for it here, look for it here, look for it there as well. Well, I always found that to be kind of annoying, especially when it's like, I know this IP address is bad, and anything that comes from it, like I want to know about right now. So even if it's a client doing a DNS query that ends up resolving to that IP address, I'd probably want to know about that happening, because if I already have it like sinkholed or something, then I'm probably not going to notice it as much because there's probably no client, or if you just have it blocked as well, depending on your logging setup and everything. But so I didn't do anything. Why did you? Ah.
No, you don't want that one.
I think we just had a. Sorry. What's up with the owls are pissed. What's going on?
It was a rat.
It might have been, man.
There we go.
Are you doing it up?
There you go.
Don't let you be people.
Does it look okay? All right. I think it's animation. You just
Animation people.
scroll down, man.
You do it.
Yes.
Now you want to do the other one. Oh, no, you got it.
Oh, that's one.
There you go. I'm sorry.
I can use Office sometimes. I swear.
It's all you.
All right. Okay. So so when you have an IP that's of interest, it's nice to just say like, hey, I know this IP is bad. So if you search for this, it would then find you all sessions that had that IP and the source destination, if it was involved in a DNS resolution, whether or not that IP address was actually in an SMTP mail header, because a lot of times where you're at your monitoring point to watch your mail traffic, you're watching it between, like, say, your Bastion, like, MX host that's out there and, like, maybe your Exchange box, so you're only seeing mail from 2 IPs. So this helps solve that problem as well. And also, especially if you do a lot of like web server clusters where you have like reverse proxies that are out in front of them, you'll have a lot of X-forwarded for headers that are actually coming into the actual servers. And usually, like, especially with a lot of our stuff, the SSL termination point is out in front of the servers, and then from there back, you might not have it anymore. So this also helps you be able to, request for sessions that are from that IP, but wouldn't be from that IP in terms of the IP headers themselves, but it still would be. So some other awesomeness, supports Yara rules, which is pretty cool. The plugin architecture that Andy has made as well, and
Right, so
sorry about Yara.
So we're starting to make it so you can expand it with plugins. We have one plugin that is included with the repository that allows you to download lists of IPs or hosts that you want tagged, and it will constantly go fetch it from an external website and get a new list of IPs that you want tagged, and if it sees those IPs or hosts, it will tag them as they go. And then internally, we have a couple other plugins that we're playing with. And then we can also tag based on other things that, such as, I guess it's basically the same thing, list of IPs. For Yara, currently, we support Yara rules that look at the whole TCP session, but we're making it so that it also looks at the email body and the HTTP body, so that you can have smaller Yara rules that don't have to first parse out the envelope. We're actively using GitHub, so if you add issues, we actually look at them and we start to implement them. So, we're taking suggestions for features that people want. Other stuff?
Yeah, that's good. Any questions?
You mentioned the single-threaded, so have you done any work with having multiple single-threaded capture processors running in the same box, listing on multiple Ethernet ports?
Yeah, so we actually do have deployments where we have one box with either 4 or 6 Ethernet ports.
Repeat the question.
Sorry, the question was, can we run multiple, or have we run multiple capture processes on a single machine? And the answer is yes, we are doing that. We actually have boxes that have multiple Ethernet ports, and we run multiple capture processes on there. Really, it all depends about how many spindles you have and what your gigabit rate is. I mean, what your rate is that you're writing out.
But yeah,
But we do it.
Yeah, we have pushed like 900 megabit a second without an issue, writing to just, JBODs.
Why did you rewrite the protocol parsers when that's been done so many times?
Excellent question. I've looked at a lot. Sorry, I suck at this. So why didn't I just reuse protocol parsers that are out there? Is the question. Great question. I think there's still an opportunity to do that. We have not rewritten a lot of them. We have rewritten some, but mainly, for example, the HTTP stuff is all being parsed by the Node.js HTTP parser. So when there's something out there that we can reuse, we are reusing it. Some of it is licensed, and some of it is just integration. A lot of the stuff out there is thread-based, and it's just not what we want. And a lot of it is around dissecting the whole thing perfectly, which again is not our goal. It's more of a let's get the information that we need to do the tagging, and then if you really want a super good viewer, which you'll see in a few seconds with the demo, you go launch Wireshark, right, which will decode it up the wazoo.
Yeah. Right. Back there?
So I noticed that when you do your capture, you're writing in. You ever thought about supporting, say, remote captures?
Yeah, so the question is, have we thought about doing remote captures? The answer is yes, we've thought about it, but currently it's not our need.
Any hope for supporting that in the future?
Sure, I mean,
Beer would be involved.
Oh, okay. Over here?
When your repository fills up, how do you decide what to throw away first? You look at administrator or retention policy?
so the question is how we decide what to delete from the PCAP repository. Basically, yes, you can configure how much free space you want on the disk. So one thing we didn't talk about is on format, all of the PCAP is stored in .pcap files. They're stored in, you get to specify, but we use 4 gig chunks. 13 gig chunks?
13.
Okay, 13 gig chunks of PCAP file, and then we index where each packet is stored so that we can instantly retrieve it. And basically what happens is you say, I want 1 terabyte free on the drive, and so it just watches, and every time you hit that limit, it deletes the oldest one.
But we also have been working with creating like the idea of standing up a separate like investigative instance of Moloch, and then your primary ones that are sitting there capturing constantly. As you flag anything or you can that you find of interest, you could then export it to your investigative instance that you just keep forever. So like you can create just like queries that would go out there to the current instance that would then pull down all the PCAP and just automatically import it into the other one. Like you can script all of this stuff, something we probably should have, probably more in the demo, but all of the requests are just done with GET requests, and the query is in the string, and then it will just return PCAP. So if you just want to script something up with curl and just do cron jobs, you can just yank PCAP out of it all day if you feel like it. Let's see, send her back over here.
When are you planning to support IPv6?
Wait, is the libnids developer here? Because we would totally like it if libnids just did it, right? But we have been looking into possibly using other, like Suricata already kind of does it, and we could probably use that setup to go ahead and do the actual capture and stream reassembly, and then kind of just merge the owls and the meerkats together, and that would probably make everybody happy. All right. I guess over here.
Yeah, let's do one more question, and then we're going to do the demo, and then we can do more questions after.
All right. Pat.
You broke this entire thing on one box instead of having like databases out here and stuff out.
Can you run the whole thing on one box? Yes. I mean, is it going to scale if you have like 5 gigabit interfaces? No. Okay.
Yeah. All right. So I guess it's live demo time. So Moloch has actually been running the whole time on the open network. So we're going to start going through it, and it should be fun, I guess. Ah. Okay. So are these like... All right. So here's our interface right here. There's a drop-down window that you can select the time window of stuff. So we'll just say like last 3 days, here's the amount of traffic, well, you know, going back to 1900 hours. And here's our cute little map. It's like, oh, that's a lot of stuff going to Russia. What's going on there? So you just click on, I'm going to start looking around for anyone with an accent and be like, I know your IP address. So yeah, if you just like mouse over it and you click it, if you notice up over here, it updated it and said country equals, you know, Russia. And then you can just say search, and then this is only the Russian stuff. So here's our timeline window. So if I'm like, oh, for whatever reason, I'm interested in this peak right here. Here's all of that data. Yeah, sure. Sorry. Is it not on? Okay. And then, so here's all, this is all just a bunch of UDP traffic and stuff. So if you click the little plus button next to it, it goes ahead and expands it, and here's the packet. So, you know, someone's just doing BitTorrent, it looks like. If you click download PCAP, it'll go ahead and, well, unfortunately, like Wireshark's kind of slow on OS X, so it'll open eventually, but I swear to God it works. I use Windows, man, I can't help it. It opens faster. So there we go. Oh my God, that's lightning speed. Holy shit. So there you go. There it is. And notice it was Wireshark opening that took the longest time. I just want to point that out. It was already exported. But yeah, like, and also if you wanted to just export, like, say, you know, like, give me these, like, these are all the sessions. If I just wanted to export these and save them, so it's like a couple hundred, you know, just sessions. Just click export, and then Andy's Mac freaks out. There we go. There's all of them that were in the view.
Okay, quick question.
Yes.
In that first view that we're looking at, is there an option to add a column for the identified protocol?
Yes, you could do that. As anyone, I'm sorry. The question was, could you add extra columns in here for identified protocol or other such things? This is the current version of the UI. Like, you could modify it. It's open source. Anyone can do it and contribute back. But one of the issues that I think we've been having was the count issue with Elasticsearch, which supposedly will be fixed yesterday or like today or next week. And then once we do that, we're actually going to revamp the UI so that as you're browsing through it, instead of a more session-based view, it would be more of a session profile information view. So as your data set that you have selected is being displayed, it would basically be like these various types of SPI data exist, and these are the counts and like IPs and stuff like that as well. So it'll hopefully look a lot different.
We're taking
soon.
suggestions.
Yes.
So please.
Yeah. Yeah, we're pretty web-centric stuff, so usually just URI, and this is usually what we end up using. But yeah, so you had some bookmarks. Let's see. So for instance, here's a custom tag we have. It's HTTP password, and we can see like, oh, there's like password stuff and URIs and things like that. So I don't know who this is, but don't get too mad, man. You're at a security conference. So it's like yeah, it's getting hashed, but you kind of just pass it, and then it just kind of works. So yeah, so that's cool. I like that. I don't know if there's any other stuff in here, but yeah, like another thing is like, yeah, with that, like, you know, so you have, let's see, like how many they have. Oh yeah, you might notice that we do ghost protocol detection. That's kind of cool. That's why we like hunting rats with it. But so if we just look at like everything that's identified as HTTP. God, Jesus.
What button do you keep?
Dude, I don't touch anything. I think it's like the cable or something, or yeah, see, I jiggled the cable. Just jiggle the cable, fixes it. Yeah. All right. So here's all of our like HTTP traffic that's been identified in the entire set. So then if we're like, okay, and we'll say, and the port destination is like not equal to 80. So we'll find like odd port HTTP stuff or whatever. And then burp, here you go. Here's all this stuff. And then it's like, oh, okay. Here's some weird ports. What's up?
Right click on URIs to export accounts.
Oh yeah, sorry. So another thing is like when you see this type of stuff, we can actually go ahead and just export all the URIs that are unique, just like that, which is very helpful, or the IP addresses as well. So here's your IP and the count that has appeared, and we found that to be very useful as well. But yeah, a lot of Salesforce activity. What's going on? What's this?
And this is only on the open up wireless, okay?
Correct. They wouldn't let us on the other one, and we had kind of debated with like, hey, if you were cool enough to come to this talk, here's the interface for this, and here's the username and password. Go nuts. But I don't know if that's cool or not. So I'll ask, and if you run into me later, I'll tell you. We'll find out. All right. How are we on time? I guess.
We just hit 10 minutes.
Oh, okay, cool. I guess we got
Do
more
Java.
demo.
Java.
Java. Okay. Yeah.
There's one Java stuff.
Yeah, so if you want to search for like, hey, who's running Java on here, and let's find out, oh wait, you got a bookmark, don't you?
That's okay.
Yeah, all right.
That's Java.
So it's like,
That's Java 37.
yeah,
Java 37.
Java 37, uh-oh, that's not good. That guy shouldn't browse the internet. Hopefully Python's not redirecting anything right now. Let's see, what else do we have? But
So then if you clicked on the IP, you could actually see what this person's doing.
oh, okay, yeah. So yeah, any of these links right here, so like these are all the different pieces of SPI data, and if you click on them, it'll auto-populate the query. So that'll add it to there. So if you just wanted to see, hey, what has this guy done the whole time, just go ahead and search, and there it is. And it's so fast. I love you, Andy. Seriously, this makes work so awesome. Oh man. Oh, word games. That's cool. That's probably why it has Java installed, so you can play like Java web apps. Goofy.
Upgrade that.
Yeah, that's awesome. Yeah. Another thing, like at least with our monitoring and stuff, is like, hey, I want to find all posts to star.su domains. Holy crap, that's awesome. There's a lot of really cool stuff in there. But I guess question, yeah.
Yes.
Yes. All right.
VI.
We do some stuff actually. Well, I guess the stats. Well, I guess we should show the stats because Andy really likes graphs. He really likes graphs.
Click the plus.
Yeah. Click the plus. Where's all the bottom stuff, man?
There's nothing that exciting. There you go.
Where's all the counts?
I don't know.
Oh, I guess we found a
No,
bug.
it's just, we only have one node. It's right there.
Oh, okay, I'm sorry. I'm so used to this being like so many more.
Yeah.
But yeah, so, this is a running total, how many packets we've captured
So right
and
now-
everything like that. I can change this to like bytes or bits or something. That sounds cooler. Where's he at, mega? Drop it.
It only
Sessions.
changes what the amount.
Oh, okay, up here.
So we're doing
yeah.
We're doing 2 megabits stuff.
Yeah, so here you can see the amount of traffic that's getting pushed through. It's not all that much because it's the open. It wouldn't let us on the other one. Makes us sad. Yes? Sorry.
So you got this installed in labs. How big is the box that's running this Moloch? Because it's pretty fast.
What is this? One little one.
So the question is, how big is the box that this is running in labs? And it's 400, it's like a half terabyte?
Yeah, it's like a half terabyte drive and 64 gigs of RAM.
Yeah. Right.
Yeah.
Right, so yes. So right now you can see that we only have like 410 gigs free. So we've captured some of that. And we're not,
It takes as much as you can give it, it's just,
right.
yeah, give one more, sorry.
And so if you look at the graph, we did a lot of traffic last night, and then we started died down, and then it started picking back up this morning.
I feel like we might have been neglecting this side because the light is blinding us. Yes.
Have you or do you plan on publishing any sanitized sample PCAPs?
Forward.
Like the practice with your new EPF language or whatever, your selection.
The question was, do we plan on providing any sanitized versions of the PCAP for people to play around with it? And we don't really have. We've had some leaks in the past that have caused some heartburn. If anyone remembers, there's like some articles and some search data. So like, I'm definitely gonna have to say that we probably not gonna do anything like that from us directly. However, I don't know if maybe Shmoocon is like, hey, here's a torrent file for all the PCAP that was on open, or like, or anything like that. Or if you just kind of go sit at a Starbucks and run air snort or I don't know, whatever else or aerosol or something, like, go nuts. But just plug it into your own cable modem, but, encrypt the hard drive, man. Yes.
So, you mentioned it sounds like you're doing gigabit. Have you tried anything close to 10 gig, and if so, what have your results been?
The question is, have we tried any 10 gig capture stuff? We have not yet. However, the disk is always going to be the limiting factor that we have found. You can throw data. We've thrown like multiple gigabit interfaces on the same box already into disk simultaneously and haven't had any problems. But once you hit 10 gig, it's always going to be about the amount of speed that you have to the disk.
So you don't think your single thread capture is an issue?
We're running like 800-900, sorry, the question was, is the single threaded capture an issue? We run like 800-900 megabit a second and do about like, 30-40% processor utilization for a single core, and it doesn't drop packets. Like our drop packet count is like nil, even when it just rolls like that.
Yeah, I think if you're going to actually do a full 10 saturated, you're going to hit a problem. I think you need to split it. There's boxes out there that will split it for you, and you would run multiple things. I think that's the current thought. I don't know if the multi-threaded is going to solve the problem. We could look at that, but currently no.
Yes.
So my question was, do you have support for parsing out the Ethernet addresses from the packet?
Not currently.
Question was, do we have any support for Ethernet parsing? And we do not, because generally where we're listening at is between two IP, or between like two MAC addresses, because we're like in between like two network devices routing data. So we don't have anything like that currently.
Could be a-
We could add it, sorry.
You mentioned ghost travel a while ago. Do you have automated detection for the OCT protocols? And have you picked up anything interesting like that?
The question was, is do we have any other type of RAT protocol detection built into it, and have we picked any of it up here at the con? I haven't gone through it too much yet. I usually rely on my IDS signatures that I have for that type of stuff, but you know, we added the ghost one in there because we thought it was cool. It's like owls like to hunt rats, but we haven't found any that I've looked through here at least, and there's no other protocol detection, no, not for C2 stuff. Any other questions, comments?
I think we're out of time.
Oh.
I got two. Number one, do you have any support for any network layer filtering out of VPN on the capture side? And the second one being, do you have plans to support parsing unified two files from source directly, or do you want to run through YouTube out and just
At least the question about unified two files, again, it's not really an IDS, and we don't generate any sort of alerting data that flows out of this. It is a supplemental. I can't hear you, man.
unified two have the PCAPs in it? That's why I was curious. Not
Okay.
saying it should be an IDS.
Okay, all right, yeah. We just pull in native PCAP. We can import that. That's it, though. Sorry. Yeah.
Do you have a process or plan for how to synchronize the distributed PCAP data over to the central source collector that might be logically far away, therefore it doesn't make sense to how to constantly retrieve the individual files as
So we're done, so we'll answer that.
Oh, you can answer
Oh, we can't answer it? Okay. So basically, right now the PCAP is distributed and the viewer processes run there, and it goes and gets it from wherever it was stored. It doesn't try and concentrate all the PCAP in one location.
Thank you very much.
Thank you.
Thanks.